Hello, this is the third video in the third Matrices series for OCR AS Core Pure Further Mathematics. We will be covering the inverse and determinant of 3x3 matrices. You should have a calculator capable of finding the determinant and inverse of 3x3 matrices. And I would pause now to check that your calculator can do both of these. The relationship for 3x3 matrices is as it was for the 2x2 matrices, t to the minus 1 equals t to the minus 1t equals the identity matrix. But obviously here, the identity matrix we're talking about is the 3x3 one. In this third series, you will use your calculator. However, in Matrices 4, we will cover finding the determinant and inverse of 3x3 matrices manually. In this 3x3 matrix example, you have A and B matrices as given, and you are told that AB equals BA equals that 3x3 identity matrix. You should pause the video now and check that B does indeed equal a to the minus 1 using your calculator. You should also remind yourself how to multiply matrices and check the result manually if you need to. This is because you can check inverses manually by multiplying the matrix by its inverse, and if it doesn't give you the identity matrix, you have made a mistake. The notations used for the determinant of 3x3 matrices are the same as for 2x2 matrices, in other words, det t, or what looks like the modulus of t. The Greek letter delta may also be used. Remember that the determinant is a number that may be positive, negative, or 0. If det t is 0, then t is said to be singular for any size of square matrix, sometimes known as n by n matrix. Here are some examples for you to try, so please pause the video and use your calculator to work out the determinants. Your calculator should have given you these answers. For the first one, 30, and for the second one, 0. Well, so what if a determinant of a 3x3 matrix is 0? If we assume that the inverse of a 3x3 matrix may be found manually by using the determinant as a divisor, for example that we did for the 2x2 matrix, then we would expect dets of a matrix being 0 to indicate a singular matrix, in other words, no inverse. Check this by trying to find the inverse of this second matrix on your calculator. You should get a math error type message. In the next session, we will consider the link between determinants and transformations.